This is part 2 for enthalpy of reactions. First part was using specific heat capacity. This I'm going to use problem 2 for an example. So usually in these, they give you a balanced equation, usually with 2 to 3, I would say, other reactions which you have to solve for to get to this balanced equation. And I'll show you how to do that. But more importantly, they each have the delta change of H, which is extremely important to find for this. So right now, I usually start with just by writing down the equations that they give us. So that'll just be 2 aluminum plus 3 over 2 O2 equaling Al2O3, and then 2 Fe plus 3 2O2 equals Fe2O3. Okay, which equals delta change of -1676 and equals delta change of H of -824. Okay. So a lot of information you don't know what to do probably. What you want to do is make sure that both of these, you use both of them, can somehow compensate for this. Meaning the things on the left stay on the left, the things on the right stay on the right. So starting off already, we have Fe2O3, and right now Fe2O3 is on the left side reactant, but on this one it's on the product side. So we need to swap this, put it over here, but in doing so, we would swap these two and put it here. So how we do that is we multiply this whole thing by -1. It changes the order that it would go in. So we would change it to Fe2O3 makes 2Fe plus 3 over 2 O2. Okay. Now, what we do to our reaction here is the same as what we do for the delta value over here. So if we multiply this by -1 to change the order it goes in, we need to multiply this by -1 as well. And so far, after this, we actually don't need this anymore because it's completely irrelevant. So we just keep this new one. So right now we have Fe2O3 over here on the front. We have that here. We have 2 aluminum over here, 2 aluminum over here. We have aluminum 2O3 on the product side. We have aluminum 2O3 on product side. And we have 2Fe on this and 2Fe on here. And ironically, for the before we even calculate this, we can check if we're doing it right by eliminating what's the same, basically. And because 3 over 2 are the same, we erase them. Which is why in our balanced equation over here, we don't see O2 at all. So we just erase this. And if it looks familiar, it's these two grouped together, the ones on the left side, the pluses, and these two grouped together, on the product side, basically. So once we have these numbers, we just do a quick calculation. So the delta H value is negative 1676 kilojoules. And this one actually becomes positive 824 because it gets timed by a negative. And once we do those calculations, that actually gives us a final H final of roughly about negative 852 kilojoules. And that should be our answer for number 2.